I am in the way of more drinks, so I'll try to keep this quick and interesting. So my name's Jonathan Chin. I'm the head of product, and I'm actually the co-founder of ARM Insight. And I wanted to start today off with something local, since we're all here in lovely Amsterdam. If you guys could raise your hand, does anyone know what this is? Okay, so some of you. Okay, so for those of you that don't know what this is called a Gable. And what's interesting about this is you see the gorgeous canal houses here in Amsterdam. They're all very tall and skinny. And that's because sometime many, many years ago, they decided that property tax would be charged based on the width of a home. So people were very smart, and they made skinny homes and tall homes. The very unique problem that created was it's very difficult to get medium to heavy furniture into your home. So another smart engineer created a Gable, which is essentially a tool that helps people move into homes here in Amsterdam. You actually hoist the furniture up, and you go through the outside. If you don't mind, I have a 30-second video that I wanted to show you on how it works.
They created a problem of their own, namely moving large and awkward furniture up the narrow staircases to the upper floors. And that's where the hooks come in. Rope is tied to a piece of furniture, and then it's hoisted up the outside of the building and taken in through either a window or a purpose-designed hatch. And the crazy thing is that this isn't some archaic, outdated system. It's still in use in Amsterdam today.
So that's how a Gable works. I do want to make it clear, ARM Insight, we are not a furniture moving company. But we do specialize in helping financial services companies move data, and specifically move it to the cloud. So I had a question. What if you could securely migrate all your data to the cloud for data science and machine learning without compromising data privacy, security, or regulatory issues? So before I dive into that, let me just prove to you we are not a furniture moving company. ARM Insight, so we have built a business on enhancing, cleaning, and transforming data for over 6,000 financial institutions in the US. We've been in business for just over 9 years, and we're headquartered in Portland, Oregon in the US. So that's all the way on the West Coast if no one knows where Portland is, because it is kind of a small town. So securely enabled data science in the cloud, we think that this is a very important step for financial services. Beyond analytics and insights, financial services, to Junta's point, produces a lot of data, and not just a lot of data, a lot of valuable data. And there's a lot of potential for machine learning and data science in the financial services industry. But I want us to all get on the same page first with what are we trying to do with machine learning, and also what are the problems that exist for financial services companies. So we all know that you need a lot of data if you're going to utilize machine learning. You need data scientists, and you need a lot of compute power, especially in financial services because there's so much data. With all that, the goal is really simple. In financial services, Junta pointed this out, we create a ton of data every single day. And we all want to use that data with machine learning to enhance our products, processes, customers, experiences, even credit offers, or all great examples of what we want to do with that. We also know that the best place to get a lot of compute is in the cloud. So if we have all the key ingredients, we know where to get big compute. Why is it so hard to get to machine learning for financial services? Or why is everyone not doing it? Why does Databricks they need Junta to sell Databricks to us? And we're all just waiting for it to happen. The reality is, in financial services, we all deal with very sensitive data. We have all types of identification numbers, photo IDs, birth dates, addresses, and everything. And anytime you work with data in our industry, it's just not simple, and it is very complex. Mishandling data in our industry actually has a lot of consequences as well, especially if it involves financial or personal information. So how do we actually securely migrate all your data into the cloud for data science and machine learning? The other thing I want to point out is some of the cloud providers. Let's go visit the cloud side now. Where do they fall short in helping us get to our goal of using machine learning in the cloud? You guys have probably seen a slide like this before. This is a classic architecture slide from the Azure Cloud team. Another one here from AWS. So in AWS, they actually start the diagram assuming all your data is already in S3 buckets. And last but certainly not least, here is a diagram from the Databricks team. And basically, where all these diagrams fall short is they've oversimplified this step of moving data from your system to the cloud. And the problem is, if you can't actually do this step, you can't take advantage of everything else on the other side of the diagram. And that's where all the cool stuff is. So how did we solve this problem at ARM? The way we solved it, working with so many banks in the US, is we actually decided we use 3 different types of data, all with different use cases. I'm actually going to focus on the last one, but I will walk you through all 3. So in the first column, you see that's raw data. So raw data is the stuff that's in your systems today. Has all the personal information. It's got card numbers. It's got social security numbers or identification numbers, addresses, birth dates, everything. This is data you definitely don't want your data science team to run wild with. There's just so much information there. In the middle column, there's anonymous data. So it's similar to raw data, but anonymous data just strips out the personal information. So you either hash the card numbers or remove certain fields completely. But what we really are excited to share with you guys about is the synthetic data. So synthetic data, similar to anonymous data, we've removed all the personal information, but so names and identification numbers are all either hashed or removed, but we've actually obfuscated some of the data by injecting mathematical noise. And you can see that the birth date has been adjusted slightly by about a month. The date and the time of the transaction has shifted a little bit, and even the transaction dollar amount. And for us, we think that synthetic data is actually the safest way to move your data to the cloud. It's essentially, sometimes we like to call it, it's like a fake copy of your data. And statistically, it retains all the same attributes as the real data. So from a modeling perspective, you won't see any difference if you modeled off the synthetic data versus the anonymous data. And it's a safer step to allow your data science team to just run wild with the data. Great, so synthetic data sounds like a great idea. How does it actually work? So if you work with ARM, we actually have an app which we call Mimic. And what it does is it's actually installed on your firewall and completely managed by the bank's team. So once we've installed the app, we're essentially hands-off. And it takes in raw data and creates a synthetic data copy. And once you have that copy, you're free to transport that securely to any cloud provider that you want. Specifically, maybe you want to use Databricks. So it's a great way to move data to that side. What I want to point out is that real data never leaves your firewall in this situation. So your data stays where it is, and only the synthetic data is what comes out. So now that we've got data in the cloud, we've made the journey to getting our synthetic data in the cloud, what did we do with it at ARM Insight, and what did our Databricks journey look like? So I'd like to start with an actual question or something that we worked with our banks on. And the question was, how do top-of-wallet cardholders use their card differently than low transacting cardholders, besides the fact that they use their card more? So this is a question we get all the time when we work with banks. It's sometimes everyone's using their American Express card. How do I get them to use my card more? And it's a real question. So our approach, we decided to deploy a logistic regression model to understand the classification of the drivers of behavior. The feature engineering, the main one that we had to do was, we call it merchant normalization and grouping. If any of you guys that have actually dealt with transaction data, you all understand that if you swipe your card at Starbucks, it does not come into the data set just saying Starbucks. And if you go to a different Starbucks, it might say something else. So we had to create a lot of normalization in where did people shop, and that was kind of one of the major features that went into the study. And the available data we used for this study was actually from our 6,000 banks. So there were 130 million cardholders in it and about 40 billion transactions. So our initial proof of concept, you can see this diagram kind of looks like the ones I showed you before. There was a step that we put in the front, which is synthesize the data so that we could freely move it to S3. At the time, Snowflake was our primary data warehousing engine. So we were kind of limited in how we could deploy Python and our machine learning models. And unfortunately, we ended up with Doug's MacBook Pro. Doug's our lead data scientist, and Anaconda running some of the modeling. And this was a proof of concept, but when we had such a large data set and we got bottlenecked at the MacBook Pro, we had to subset the data so much. And so the problems we had was the subset was so small that it really wasn't representative, in our opinion, of cardholder behavior. And obviously, that's just not a scalable solution for deploying this to 6,000 banks. Because at the end of the day, our goal was we wanted to study how cardholders do this. We wanted to create a benchmark, and we also wanted to show the banks how their cardholders behave in comparison to the overall benchmark. So our scalable production architecture, that's where Databricks came in. We started shopping around, how are we going to do this in a more scalable way that's repeatable? And so obviously the first step's the same. We're synthesizing the data. But then Databricks and Delta Lake are actually, and Spark are doing most of the workload. And this allowed us to essentially open up all the data to be used in the modeling. And we also added a real service layer where banks could log in through Tableau. And we are looking into removing the Snowflake piece and using Delta Lake. So that's something we're experimenting with currently. But like I said, this allowed us to use all the data available to us. And that really gave us the opportunity to create, like I said, a benchmark cardholder behavior where you could see the top of wallet cards from all the banks and the low transactors. And then each bank, when they logged in, they could see how their cardholders behaved in comparison to that benchmark. And jet speed with Databricks, I know some of these questions came up earlier. We basically were able to stand up the data warehouse and migrate from Snowflake to Delta Lake in just 2 months. The system is fully automated end to end. We have hourly updates. It's not streaming because we're actually not in the off stream. We're an analytics platform, so we receive data externally. So we stream the data in hourly, and there's about 2 to 3 million transactions that come in. Like I said, end to end means all the features are added and all the modeling is run, and then it's distributed and available to banks. And then, we got all of that up and running with just 2 data engineers. Databricks provided a lot of tools that these guys could just code and deploy, and I didn't need to have an entire team to figure out how to get this operational. Now, I do have to make sure it works, and there is a team that is monitoring that. But as far as building, we only needed 2 engineers. I know you guys are all wondering, like, well, what the hell happened with that study? And so I do want to share that with you. But before I get there, I want to introduce you to a new acronym, and this actually came from our study. It's called FLUIP, and I know you're wondering, what the heck does FLUIP mean? So let me show you. It is not. What you're looking at here is a summary of the data study we ran on all 6,000 banks. And what we called top of wallet cardholders, we called those high transactors. And the low transactors were essentially the non-top of wallet cards, so cards that transacted very few times. On the x-axis, you'll see we've got categories, merchants, and groups of merchants of spend. And on the y-axis, that's the percentage of cardholders who transacted in that bucket. So some of this data is interesting and not surprising. So restaurants, for example, you'll see restaurants is the top category in both low transactors and high transactors. That even looks like a potential opportunity where you might be able to convert a low transactor into maybe a medium or a high transactor if you encourage them to spend more at restaurants. And I know we're picking on Chase, and I think Chase has a rewards card that gives you 3% cash back if you spend at restaurants. But if you look at the opportunity in other categories, like pharmacy or FLUIP, you'll see that there's actually a bigger behavioral opportunity shift there. It's only a 3x opportunity in the restaurant, but the drugstore and the FLUIP categories show a 10x and a 9x. And what that means in theory is that we saw that there was such a disparity between low and high transactors in these categories that might be actually a better indicator or a potentially better motivation to create a high spending transactor if you push them into those categories. And so specifically, I don't need to go into what pharmacy spend is. You guys know what that is. But I will go into FLUOPS. So FLUOPS stands for food delivery, Lyft, Uber, iTunes, and PayPal. So when we grouped these merchants together, we saw this behavioral opportunity, and it just really pointed out to us that, oh, well, why is that? And we thought through, these are all online merchants. This is kind of what we thought. They're all online merchants that are all growing in popularity. They're all high transacting merchants as well, and they all require a card on file. And all of their interfaces make it super easy for a customer to just click and buy. So that was just the opportunity we saw, and what we did was we actually told our banks that we shared this study with them, and we told them that if they helped encourage these FLUOP merchants, that could help change these low transactors into medium and maybe high transactors going forward. So some banks are still working. I mean, banks don't always just listen to us, but they look at the data, they'll take some time, create some marketing programs, but I don't have the results if that's actually working right now, but that's kind of what we saw in the study. So the goal is still really simple. In financial services, we still are creating a ton of data. We all obviously want to use machine learning on all of our data to enhance our products and our offerings to our customers. And from our perspective, synthetic data is the safest and securest way to get there. It's an easy way to just move your data into the cloud and have your data science team use Databricks, for example, and deploy machine learning. So it's kind of like a data Gable in a way. Thank you. Dankjewel. Is that? Any questions?
Thanks. This is an interesting take on the on-premise cloud. What are the latencies that you have when you are making the data synthetic?
So since that application actually lives on-premise with our banks, it's actually it's a really lightweight app, but it actually is, the bottleneck is more the server that they've dedicated to it or the cluster. So some banks are pretty old school and they're on-prem, and I literally just get a single VM box. Some have, some better clustering, and it really just depends. It's kind of something that is dependent on that.
Synthetic data, I think, is really interesting. But do you know if it would be legally possible then to start selling it?
That's a great question. So in the
Asset manager are always interested.
okay. So one, I need to give you my business card after this. But so in the U.S., so we're headquartered in Portland, and we're in the U.S. In the U.S., we have had our legal team and external legal team work with us on synthetic data, and that is something that, depending on our agreements and the bank's rights to that data, synthetic data is a safe way to monetize, and that's actually a big part of our business and our value prop when we work with banks. We help them monetize their data internally and externally, and asset managers are one of those sources. To James's point, they actually love transaction data, and so we do help facilitate that.
Even in the case, okay, just building on that question, hypothetically, even in the case that, let's say there is a user and you make this data synthetic, when you run a machine learning algorithm and you are doing there is a model output and you are doing some prediction, and then this user invokes the right to be forgotten.
Mm-hmm. So in the U.S., so in the U.S., like right now, the bank is GLBA is essentially the large reg that's governing this type of data, and in that case, the synthetic data is separated, is treated separately. Now, I know we're in Europe, and GDPR is the big buzzword, and we're currently working with our legal team and actually some DPAs because it doesn't technically address synthetic data in itself. There's pseudonymized data and anonymous data. But we're not trying to trick anybody in conceptually how this works. We just think this is just, we want to push the boundaries for what does privacy mean or what data security means, right? It's instead of more encryption, like if we synthesize the data a little bit without losing kind of the statistical attributes, it is a safer way to do it, and we want to work with the DPAs in that concept. So I just don't know right now off the GDPR stuff.
So do you see Google Atlas as something which is doing something?
Oh, so their new API that they released on the differential privacy. Yeah, so that's
That's common. I'm forgetting. It's a common engine for on-premise and cloud.
I'm not familiar with. I'm not familiar with that. Sorry. Yeah.
When it comes to the synthetic data, I guess there's two things that we care about. First of all, is to have it as good as possible, so when you can implement you want to get the same results on the synthetic one as on the original one.
Mm-hmm.
But I guess that you can figure out, and you've done that inside the mimic.
Oh, the mimic engine. Uh-huh.
But then the second part is, and this is where I think it gets very interesting, is when you take the original data, you already use some attributes, and you want to then change some of those attributes. How do you know when it is enough? Are those requirements given to you by the bank? And where does the responsibility come in that case? What if at some point the that data is not good enough?
So that's a great point. So so our mimic app has variables in which how noisy do you want to add, how much noise do you want to add to the data set, and that is something we work with our bank. So every deployment of mimic is customized to the bank's, I guess, how comfortable they are, and that is the risk. We like what you call epsilon in differential privacy. We have a similar concept where you can add more noise or less, but it does diminish the value. But realistically, that's something we work with the banks on, and it's kind of their decision on how comfortable their compliance team is with the noise. But you're right. I mean, if it's too noisy, then it's not going to work, and that's just the risk. So, any other questions?
That's awesome. Well, thank you so much, everybody, for joining us today. So there's drinks outside. Thank you very much to ABN AMRO and Arm Insight for your wonderful presentations. These are two companies that are not suffering from Inchecklichkeit, complacency. So we hope that next year you guys will be on stage with us to do a similar presentation. So thank you so much. There's drinks outside, and look forward to connecting with you guys. Thanks a lot.